So guys, welcome to our channel once again. In today's video on our JAMB Chemistry exam revision series, we have here these 10 JAMB repeated questions to answer on the topic kinetic theory of matter and gas laws. So guys, in short, stay till the end of this video, and if at any point you feel you want to answer any question here, you can always feel free to pause this video and try out to see if you can get the answer to the question even before we provide the answer thereafter. So guys, the first question we'll consider here is an increase in the pressure exerted on a gas at constant temperature results in A decrease in volume, B an increase in volume, C a decrease in the number of effective collisions, D an increase in the average intermolecular distance. So guys, the answer to this question would be option A, and that's a decrease in volume. So let's recall that according to the Boyle's law, the volume of a given mass of gas is inversely proportional to its pressure, provided the temperature remains constant. So guys, in this case, the answer to this question will be option A. So let's consider the next question, guys. That's question number 2. So here the question says, Dalton's law of partial pressure is expressed mathematically as, option A here says, P for subtotal is equal to P for A plus P for B plus P for C, and so on. Then B says P for total is equal to P of A plus P of B plus P of C, and so on. So option C here says P of A is equal to P of A plus P of B plus P of C, and so on. So option D here says P of B is equal to P of A plus P of B plus P of C. So guys, for this, the answer to this question, like we all already should have known, is option B. That's P of total. That's the total partial pressure is going to be P of A plus P of B plus P of C, and so on. So Dalton's law of partial pressure is expressed mathematically in this form. That's option B here. So let's consider the next question, guys. Question number 3. It says, a given volume of methane diffuses in 20 seconds. How long will it take the same volume of sulfur dioxide to diffuse under the same condition? So guys, we're going to zoom into our workspace here and solve this out together. So over here, let's make use of the formula. R1 root D1 will be R2 root D2. So guys, with this, let's calculate the molecular mass of methane, and that's CH4. So C is 12 plus H is 1 times 4. So H is 1 times 4, and that's 4. So this will be 16 grams. And then let's also do the same for sulfur dioxide. So sulfur is 32. Then oxygen is 16, then times 2 is 32 as well. Then times 2 is 32 as well. And that's 64 grams. So guys, having gotten this will be our D for the D1 and D2. So the next thing we are going to do is to equate 1 and 2 here. So we have R1 D1 is equal to R2 root D2. But then guys, we're going to substitute our R to be V over T. So in this case, you're going to have V1 over T1 root D1 to be equal to V2 over T2 root D2. So guys, at this point, we're going to substitute every other thing here. And remember, we are looking for our T2. So from the question, we have that V1 will be equal to V2. Since the question says a volume of methane diffuses in 20 seconds, how long will it take the same volume of sulfur dioxide? So if V1 is equal to V2, and they are both numerators here, so we can cancel these out, and then this equation now becomes root D1 over T1 is equal to root D2 over T2. So we're going to just wipe off these other parts of this so we can have better space to solve right here. So now we are at this point. We are going to go ahead and substitute for D1, T1, and D2 so we can get our T2. So remember, we are looking for T2, which is the time for the sulfur. So here we can say we can cross this and multiply. If we want to make T2 the subject of this equation, we can say T2 root D1 will be equal to T1 root D2. So with this, you can say T2 is equal to T1 root D2 over root D1. So here T1 is 20 seconds. And then root D2 is going to be root 64 from what we got. Remember, we got D2 to be 64. That's for sulfur dioxide. D2 is for sulfur dioxide. And then for methane, which is D1, we actually got 16 grams. So let's not forget this. So we're going to use them here. So root D2, which is root 64, and over root D1, that's root 16. So guys, at this point, you will always need to at least have an idea of some of these your roots, because your JAMB calculator won't allow you to calculate roots. But then we know that root 64 is going to be 8, because 8 times 8 is 64. So here we're going to have 20 times 8 over, so we know that root 16 is going to be 4, because 4 times 4 is 16. So here it's going to be 8, it's going to be 20 times 8 over 4. And guys, this is going to be 20 times 2, since 8 over 4 is 2. So this will be 40 seconds. So guys, the answer to this question here will be 40 seconds. Let's go ahead and wipe this out. And the answer to this question, guys, is option B. That's 40 seconds. So let's consider the next question, guys. Question number 4 here. So the question says, what is the state of matter in which particles are widely spread and move freely with high kinetic energy? A, plasma, B, solid, C, gas, D, liquid. So guys, the answer to this question is gas. As a gaseous state, the particles of the matter are widely spread and they move freely with high kinetic energy. And guys, that's the answer to this question. So let's consider the next question. Question number 5. It says a gas exerts pressure on its container because A, of the collision of the molecules with each other. B, some of its molecules are moving faster than others. C, the mass of the molecules of gas. D, the molecules of a gas collide with the walls of the container. So guys, a gas actually exerts pressure on the container because the molecules of the gas collides with the walls of the container. And that's option D, guys. So let's consider the next question. Question number 6. It says 30 cm cube of hydrogen was collected over water at 27 degrees Celsius and 780 millimeters of mercury. If the vapor pressure of water at the temperature of the experiment was 10 millimeters of mercury, calculate the volume of the gas at 760 millimeters of mercury and 7 degrees Celsius. So guys, let's zoom in right in here to our workspace and solve this out together. So here we need to consider first of all the equation we are going to use for this calculation. So since we have temperature, we have pressure, we have volume, we are going to use our P1 V1 over T1 equals P2 V2 over T2. But guys, then let's recall that, all right, our volume first of all is 30 cm. That's our initial volume. So V1 is going to be 30 cm cube from the question. So our initial temperature here, it's going to be 27 degrees Celsius is 300 Kelvin. So if you're wondering how we got the 300 Kelvin, 27 plus 273. So for you to convert from Celsius, from degrees Celsius to Kelvin, you have to add 273. So that's the temperature. Then guys, for the pressure here, in order for us to know the pressure for this hydrogen gas, we actually collected this hydrogen gas over water. So we are now given the pressure for both the hydrogen gas and water, which is 780 millimeters of mercury. But then the vapor pressure of water at this temperature was also given to be 10 millimeters of mercury. So in order for us to get the pressure for the hydrogen, we are going to just do the total pressure, which is 780 millimeters of mercury, then minus 10 for the water. So that would be like 770 millimeters of mercury. So this is all for these parts. So let's check out for this part. So V2 will be unknown since we are asked to calculate the volume of the gas. So already we know that V2 is unknown. Then T2 is the second temperature given to us, and that's 7 degrees Celsius. That would be like 280 Kelvin. And then for the P2, we have 760 millimeters of mercury from the question. So we all have all our parameters set now. So the next thing is to just solve this by making V2 the subject of this equation. So V2 here is going to be P1 V1 T2 over T1 P2. So guys, if you're not yet good with making any of the variables the subject of the equation, guys, that's one of the easiest things you can do by just making a cross this way whenever you have things that you want to make one the subject of the formula. So it means that this everything here goes with everything here, and then everything here goes with everything here. So guys, any area where you have the variable you want to make the subject of the formula, the rest of the parts from that area will be the denominator. So guys, this is an easy way to explain this. For instance, I'm making V2 the subject of the formula. V2 goes with everything along this side, so it goes with T1 and P2. So it means that T1 P2 will be the denominator for this, whereas this rest will be the numerator. So guys, this is an easy explanation of this. If you don't still understand this, you can still let us know via the comment section below. So guys, that's it. P1 here is 770, since it's 780 minus 10, so that's 770 millimeters of mercury, then times V1, that's 30 centimeter cube, and then T2 is actually 280 Kelvin. So this will be over T1, which is 300 Kelvin, times P2, which is 760 millimeters of mercury. So guys, with this outlined here, we can do 770 times 30 times 280. So this will be 6,468,000. And this will be over 300 times 760. That's 228,000. 228,000 here. So guys, let's calculate this out together. It's 6,468,000, then divided by 228,000. That's 28.36, and that's approximately 28.4 cm cube. So guys, that's the answer to this question here, and that's option D here, guys. So go ahead and wipe this, and then let's consider the next question. That's question number 7 here. So guys, the question says the basic assumption in the kinetic theory of gases that the collision of the gaseous molecules are perfectly elastic implies that the A, force of attraction and repulsion are in equilibrium, B, gaseous molecules will continue their motion indefinitely, C, gases can be compressed, D, gaseous molecules can occupy any available space. So guys, the answer to this question is option B here. Gaseous molecules will continue their motion indefinitely. So this actually implies that there is no loss of energy after collision. So that's the basic assumption in the kinetic theory of gases, that collision of gaseous molecules are perfectly elastic. So let's consider the next question. Question number 8. It says, an increase in temperature causes an increase in pressure of a gas because A, it increases the number of collision between the molecules. B, it decreases the number of collision between the molecules. C, it causes the molecules to combine. D, the molecules of the gas bombard the walls of the container more frequently. So guys, the answer to this question here is option D. The molecules of the gas bombard the walls of the container more frequently. So let's consider the next question. Question number 9. P1V1 is equal to P2V2 supports A, Avogadro's law, B, Boyle's law, C, Charles' law, D, Graham's law. So guys, I see this to be more like a bonus, and I believe you already know the answer to this question, and that's Boyle's law. So let's go ahead and consider the next question, and that's the last question for this video. Question number 10 here, it says, the partial pressure of oxygen in sample of air is 452 millimeters of mercury, and the total pressure is 780 millimeters of mercury. What is the mole fraction of oxygen? So guys, for this, we're also going to simply zoom into our workspace here and just do this together. So mole fraction will be partial pressure over total pressure. So take note of this. Mole fraction is partial pressure over total pressure. So we are given the partial pressure of oxygen here to be 452. And then the total pressure here was given to be 780 millimeters of mercury. So guys, with this, 452 over 780, that will be 0.5794 whatever, and guys, that's 0.579. So guys, that's the answer to this question, and over here it's option C. And guys, let's go ahead and wipe this. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So guys, we also want to use this opportunity to encourage you to join our YouTube channel community. So guys, this is where we'll post updates and share information based on your JAMB. So guys, you can't afford to miss this offer. It's a very nice one and will help you even as you prepare for your JAMB examination. So you can join our YouTube channel community by clicking on the join button below, and then you'll be a part of this community where you get premium information and updates regarding JAMB examination. So guys, that will be all for this. Thank you once again for watching this video, and see you on the next one.